And first thing I'm going to do is I'm going to share my screen with you. And you should be able to, let's see here. You guys see that? No.
We're
no.
looking at you, not your screen.
How about now?
Yep.
There it is.
You guys seeing this?
Is the Excel sheet.
Hello?
Yeah, it's an Excel sheet. That's what
Oh.
we're looking at.
I'm not hearing you either.
We're looking at Excel. Can you hear me?
Something's goofy. Hang on.
Now your voice isn't going through.
Brad?
There you are.
Are your
Brad, are you hearing me?
Yeah, I can hear you.
Yeah, I can hear you.
Ben, do you hear me?
Yes.
his input and output like default devices are
Are you guys
incorrect,
hearing
probably.
me?
We are hearing you, but you're not hearing us.
And how come nobody said yes? I can't hear you. Nathan, talk.
So can you hear me now?
Got you. What's going on here? Hang on. All right. Now,
Hello?
yeah.
Can you
now
hear
I
us?
hear you. Got you. All
Hey.
right. Thanks. Okay. Sharing the screen again.
All right.
Hello?
Yeah, I can hear you now. All right. So you guys can see this, I'm hoping.
Yeah, we can see it.
You're seeing an Excel spreadsheet?
Yeah.
Yep.
All right. All right. Let me minimize me over here. All right. So basically, right now we're doing procedural programming. So there's 3 things that we can do. And the first one is sequential. The second one is decision. And the third one is repetition. Repetition, I think it's like that. So those are the 3 basic things that we do in procedural programming. Okay. So these are what we need to learn before we can do other stuff later on. Okay. The scenario, these are based on the sequential one, of course, is we do that, then we do the one after it, then we do the one after it. We can't skip any, right? Same thing with the decision one. The decision one, though, allows us to go, well, if something is true here, we can go over here instead of going down one at a time. Or it may not do anything. If the decision isn't true, the program might not do anything at all. Okay. And then, of course, repetition is you keep doing it until something becomes true or false. So we have those 3 structures to deal with. To use them, right now we've been using arithmetic operators, but now we need to do relational operators. Oops, and I have to be able to type tonight. Jeez. So we got relational operators. And the deal with relational operators is they always are Boolean. Which means what? Somebody. What's Boolean? Yeah, they're true or false. Okay. So the main ones are that we use that are relational are equals. And again, note, oh, stop. It doesn't like that. More than or equal to, less than or equal to, greater than, less than, and I think, what is it? Not equal. It's like that. So those are the basic ones. Okay. So we have something here. Is it equal to something here? Okay. Just a plain equal sign, of course, is an assignment operator, and it's not a relational operator. So most of us are familiar with these, okay, from doing math or algebra or whatever. Then after we do those, we have the logical operators. Not, oops, not, and or. So basically it looks like, I think I got them here. Where are they? Right here. Okay. So here's our operators. Here are math operators. Of course, parentheses come first, then exponents, then your basic multiplication, division, and remainder, or modulus, addition and subtraction, then your relational operators, is and is not, don't worry too much about those. Then you got not, and or, which is the lowest. So let's take a look at not, and or for the most part. So those we need, basically have to understand the truth table for them. So we got not, which is, let's see if we got true and false here. So if it's not true, it's false. And if it's not false, it's true. That's how simple that one is. And is a little bit different. Oh, stop. And that is, if I have a true here and a false here, and I have a true here and a false here. Okay. So if I, let's see here, Christina, I need you to answer these questions, okay? So we're taking computer science 145. That's true or false?
That is true.
Okay. And we're taking it at ICC.
That is also true.
So I've got a true and a true. So if I say the whole thing, I say, we're taking computer science 145 at ICC.
That would come out as true.
Right. Okay. So that one is true. So if I told you we're taking computer science 145,
That's true.
and we're at Black Hawk College.
That is not true.
So if I say we're taking computer science 145 at Black Hawk College, the whole statement is,
False.
yep. Still in there. So now we're taking English 110,
That's false.
and we're taking it at ICC.
That is true.
So we're taking English 110 at ICC. The whole statement is,
false,
Yeah. And the last one is we're taking English 110.
that's false,
And we're taking it at Black Hawk College.
that is also false,
So if we say we're taking English 110 at Black Hawk College,
false,
yeah. So we can generically say what, Joe? What can we basically say about an and statement?
Only true if both requirements there are true.
Yeah. So it's only true if both of them are true. So is there any time when if the first statement or the first comparison is false, that this and can be true?
no,
No. Okay. So I will tell you that Python will short circuit that. Okay. In some languages, that isn't true. What I mean by that is if you have a comparison like that, once it's false, it can never be true. So it doesn't go on and do the other. I mean, you don't know that, but it doesn't keep going. So it does it a little bit faster because it doesn't need to do the second one. It really doesn't. All right. So if I have an or here, though, this is true, and this is false, and this is true, and this is false. So let's see, who else do I have here? Caleb, you with me? I think some of these guys log in and then go home or something. Okay, how about Brad? Brad, you there?
Yeah.
Okay, let's see here. We're taking computer science 145
True.
and we're at ICC we're taking it at ICC.
True.
So if I say we're in computer science 145 or we're at ICC, it is
True.
true, right? All right. So now we're taking computer science 145
True.
and we're taking we're attending Black Hawk College.
Be false.
Okay. So if I say now we're in computer science 145 or we're at Black Hawk College, the answer is
The statement would be true since we're
it
at
would be
145.
true. Okay, Brad. We're taking English 110
False.
and we're at ICC.
True.
So now I'll say we're taking English 110 or we're at ICC.
The statement would be true.
Yep. And now we're in English 110
False.
and we're at Black Hawk College.
This will also be false.
So if I say we're taking English 110 or we're at Black Hawk College,
So that whole thing would be false then.
yeah. So Justin, what can I basically say about the or statement?
Both of them have to be false in order for it to be false.
Yeah,
If one's
generically.
true, then it's true.
Yeah.
If at least one is true, then there.
At least
it's
one is true. So on this one, I can't really short circuit it, can I? because the second one really determines whether or not because the first one could be false, right? But if the second one's true, it's still true. So the short circuit thing doesn't work here. Well, it does. I guess it does in a way. If the first one is true, can it ever be false?
No.
No. It'll always be true if the first one is true. Okay. Okay. That being said, be careful when you use not. Okay. I'm not saying not to use it, but it gets complicated a lot faster when you do, because you start negating stuff. Like if you have a compound, like if you were to say, that, I don't know, I'll just type it out because it's hard for me to do. Usually I'm on a whiteboard, right? So let's say we have somebody that's a student. Okay. And let's say this is a gender is female and age is 27 and veteran is false. Okay. So now we're going to try and determine if this person's going to get financial aid. Okay. So we might have something like, if I'm just going to type this out, it's not going to be in. If the gender is equal to female and the age is greater than 25, or veteran, I'll just put vet, is equal to true. Okay. They get financial aid. So would this person get financial aid would be the question. James, what do you think?
Yes, they would.
Okay. Anybody think they wouldn't get financial aid? Nobody? He's right. Okay. So we got, it says if the gender's female, so that's a true. And, oops. And then is her age over 25? Yes, it is. So we have a true and a true right there. So a true and a true would be equal to true. Come on. So true and true would be equal to true. Okay. Then we've got an or here. Well, in reality, it would short circuit out right there because this is true. And now we got an or. So it has to be true. She's going to get financial aid. But we could keep going here. And then this one over here, is she a veteran? No. So that's false. So first of all, by order of precedent, so this would be a false down here too. Okay. So now we'd have a true or false. And so our answer down here would be true. She would get financial aid. So if I do this, put it over here. Let's see if it'll put it there. Okay. So now let me change this a little bit. So this is a male. Or and let's see. So this one over here is going to be a gender is male. He's 21. And he is a veteran. And then we're going to come back here. I don't know why I typed that uppercase. All right. So on this one, Andrea, what do you think?
There we go. Okay. Male would be true and vet would be true. So he would get financial aid.
Okay. So again, so here, what are you going to do first here?
Well, the and takes precedence over the or.
Right. So is he over 25?
No.
Okay. So we got a false and he is a vet though, right?
Yeah.
So that gives us a false there. Okay. And then we got here, so then here be an or. But and his gender is male, and so this one is what?
True.
True, right? So now we've got a true or a false, and so that gives us true. Okay. So you got to be careful on that one because the and is over here. So it's done before the or over here. So if this would have been a female, they wouldn't, let's see. Yeah, if this was a female up here, they would not have gotten financial aid. Okay. So just be careful. And then you, like what I was trying to say though before was if I throw a not in here, then it just gets more complicated, right? If there's any way to get around, like if you said, if gender not equal to female, well, that's silly. Just change it to if gender is male, right? And believe me, it gets a lot more complicated than that when you start messing around with what I call negating your truths and falses. There's sometimes we have to use them, but other times not so much. So we need to understand the order too of how to do it. Okay. So we're going to take a look tonight at the if statement, and there's three are decisions, and there's three basic structures we're going to use, or keywords, and it's if, else, and elif. It's instead of else if in some other languages or that, it's ELIF. Okay, ELIF in this language, in Python. Okay, something like this. Okay. Like that. Okay. So I'm going to start Thawny. Oh, you know what I want you guys? Hang on one second. Let me talk to you here. I got to bring up the. What I want you guys to do right now, let's see, I got 428. Okay. I want you to type in like Notepad, just type the word I am here in Notepad. And now within the next minute, I want you to save it to your portfolio. I'm just seeing who's here and who isn't, like if they logged in and are not here. So I can look and see who did that and who didn't do that. It's kind of like an attendance thing, right?
I don't think I have a notepad on Mac.
It don't, it's in something, send it to me in a whatever. Or just put it in your portfolio that you were here at 429, 430, whatever. Okay, everybody good? Then I can see the timestamp on it. And okay, oh boy, oh boy, oh boy, it's always something.
They're going to tell us the percentage that are actually here.
No,
That'd probably be pretty funny.
it might be. Yeah, we're gonna, and I'll believe me, I'll be talking to them. All right. So I normally do a program. I think we'll do this one. In class. And it's one of the ones for that we're going to do anyway. So I'm going to call it project. The Acme Tavern validator. And we're going to save it as file. Age validator. And it's, what do you want? My dog is sitting here, like she's as tall as the chair I'm sitting in, and she has her head on the keyboard right now. Date is 28 Jan 2021, and the author is you, and the purpose. A program based on a user's input of their age states what, if any, alcohol product. You can't type. You don't have opposing thumbs. Something to that effect, okay? So basically, we're just going to ask the person, you know, what do you want to drink? So we're going to say print. And then age will be equal to an int input. It's not time for you to eat yet. Go lay down. Oops, I'm missing a. That's better. All right, so now there's a couple ways. So if I say if age is less than or equal to, let's make it 12. And in Python, we end our conditional statement with a colon. All right. So that brings us back to here. Notice the indentation that we get at that point. So here I can just say print. Okay. Let's see what else I got here. And then I'm going to do this in a couple of ways. So this will say else if age is less than or equal to 20. Print you will drink soda. Else if age is less than, let's say 40. Print you will drink beer. else. Oops. I always forget those colons on the ends. Drives me nuts. Oh, let's call it 40. How about 63?
Wow, wind, huh?
Oh, wind. Yeah, sorry. You will drink the wind. And then this one, we don't need a comparison. Why?
It just covers any other condition.
Yep. Because there's nothing else left, right? We've eliminated everything underneath that. Okay. So let me see here. Get this thing. This thing's always in my way. Da, 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 da. I think I got. I need anything else? I don't know. I don't think so. See if anything comes okay. So what did I say we were going to call this thing? The age validator. And I'm going to put in that I'm, yeah, right. Okay, well, we'll put me in. I'm 68. Okay, so that works. How about if I put in that I'm 13? So it seems like it's working okay. So we'll save that one, okay? So you see what happens here. It drops out, it falls out, falls out, falls out, falls out, falls out. And then we're only left here at the end with this one. So, and again, if it does this one up to here, it doesn't do any of these other ones. Okay. Now, let's take a look here. I could do this. Okay, so we got this one saved. Let's see if we can save as. Okay, I'm going to save it as validator number 2 now. Okay, you guys know how to do that? So now we're in validator 2. Our first one ran fine, right? So let's do this. Let's take out this else. Do that. Take out this else. Leave that. These need to be indented. Take out this else. Oops. All right. So these are called inline ifs. Okay. And I was going to show you what happens here before we fix it. In the good old days, when all we had was ifs, and some people still do this. The problem with using these types of ifs are, first of all, this. So a 12-year-old drinks milk, soda, beer, and wine.
Right. So all those ifs evaluate to true.
That's right. Okay. So we know we don't want that. So we have to add. Okay. So on this one here, we have to change it to read. And this one here, we need to do. One, right? Last one's still good, I think. I think that's still good. Now let's try it. Okay, drink milk. That looks good. Let's try something else. And that looks good there. So now this works. No different than our other one. What's the difference here, though?
Only one of them will execute because whatever number you offer is going to fall into one of them. And not
Yeah,
the
but
others.
that's just like the one we did with the else ifs, right?
Sure. Yeah.
Okay. The difference here, I would argue, is this is the slowest method. Why is it slower than the other one?
Because
Slow
it's still
to-
going to evaluate all the ifs. And then it's
Yeah,
going to have to check two
like
conditions.
if I type in 12 here, it still goes down to this one. Then it goes to this one. Then it goes to this one. And then it finally goes to this one. So it has to run all the evaluations, right? So it's a little bit slower than doing it with the else and the ifs. Because once it finds one over there, it drops out, right? Okay, so let's save this one. Or I guess it's already saved. All right. So now let's go ahead and save this as age validator 3. So now it's age validator 3. So I'm going to get rid of this, that stuff we added, okay? So we can delete that. We can delete that. And we can delete that. Now my dogs are snoring. So that's always a nice thing too. So we got that, okay? So now what I'm going to do is this. And I'm going to go ahead and save it and run it. And let's try our 12 again. That seems to work. And if we try 37, let's say, that's a beer. So this works. So what do we here is the same as our age validator, the first one we did, but it's a lot easier to interpret. Okay. And it uses a lot less typing, a lot less space, you know, not as much worrying about indentation. So this one here is just as fast as the first one we did. The only slower one is the second one. All three of them can do the same exact thing. It's just a matter of, in other words, I would stay away from the second one. It's just too old fashioned. But there are times, again, sometime in your career, you might have a case where you have to have a bunch of inline ifs. Okay. Any questions over the basic format? Okay. So this one here that we did, these three or whatever, if you want to just put one of them, probably this one, in your portfolio, this will count for, you have a homework assignment that's like age something or another. And it says that if they're under this age, they're a baby, this age, a child, et cetera, et cetera. We'll do our drinking one as our, it'll count for your age validation. Okay. How's that sound? No,
All right.
yeah.
That's sweet.
Is that cool? All right. Let's try something else here. Let's get a new one. And this one, all I want to do is show you um, uh, all right. So, when they first decided to, when we first started doing computing, for example, they needed a way to, again, computers are the dumbest. I mean, the only thing a computer can do is say, is it on or is it off? That's it. Basically, you know, it's a bit, one bit, and either the circuit is open or the circuit is closed. So when we started thinking about how are you going to represent text or numbers, somebody had to come up with something. Okay. So the idea again of the bit being true and false, it really wasn't very adaptable to the decimal system, right? Okay. So that's the first thing. So we ended up with binary, a series of zeros and ones. Okay. And that really determined what we get. And then somebody decided that we would use 8 bits to create something called a byte. Okay. And a byte is about 1 character, somewhere around a byte. Okay. So then once we had all that settled and they came up with something that's called ASCII. Okay. So we'll put that up at the top too. So when we compare strings, we compare them by ASCII value. And what that is American Standard Code for, let's see, what is it? Integration. I forget what it is. American Standard Code for the integration of information or something to that effect. And the way it works is this. So let's see here. Let me tab over here. Oh, stop. I don't want that. What they did, okay, so escape. So the uppercase is equal to 64, 32, 16, 8, 4, 2, 1. So that is equal to, that's base 2, is equal to 65 base 10. I'm sorry. Yeah, 65 base 10, which represents a capital letter A. All right. So basically what you have here is you got 1, no 2s, no 4s, no 8s, no 16s, no 32s, and 164. So 64 in 1 in base 2 is equal to 65 in base 10. And somebody out of the blue says, okay, let's go ahead and make that the capital letter A. Okay. So there's 26 capital letters. Okay. So then the lowercase, okay, so you think how many letters? So there's 26 capital letters. So if I add 26 on to 65, I get what, 91? Right? So you would think the lowercase letters would start at 91. But somebody says, no, we can't do that. The best way to do it would be just to turn on, send electricity through that bit right there. So a small letter A starts here on the 32,000,001. So base 2 is equal to 97 base 10. is equal to a lowercase a. Okay. And then you got, so the numbers that are missing are punctuation and stuff like that. And I'll give you one other one that's a common one. And the numbers are down below 65 digits. Okay. A space character is equal to 32 base 10. Okay. So that's how they're compared. Okay. So let's try this. So let's do it this way. Let's just do name 1 is equal to input, enter the first name, and name 2 is equal to enter the second name. And then if name 1 is greater than name 2, print and then else, or let's see, name 2 greater than name 1, print name 2 is greater else print the names are same. And I'm going to go ahead and save that as compare strings. And I'm going to try and run it. See if I get an error. I did. The names are the same. Oh, forgot a double quote right there. Save again, run it, hopefully. And so we'll put in Doug and Robert. Okay, Robert is greater. Let's try, and that's because the capital letter R is more than the D there. Let's try Doug and Don. Okay, so here it does the D and D is the same, O and O is the same, U and N. The U is a higher number than the N, so Doug wins that one. And what if I just do Doug and Doug? The names are the same. So in any, I mean, whatever programming languages you're taking, you should be familiar with ASCII, okay? There is another one that they use in more mainframe. It's called EPSIDIC. I have no idea what it stands for, but there is another It's based basically again on the binary, but they use that. And of course, this binary thing goes on when the numbers, the problem with binaries, the numbers get so big so fast, right? That we also use hexadecimal when we're just talking about things like memory, and also octal, because they're all easily converted from one to the other. Okay. So again, if you've never looked at ASCII before, take a look at it. You can just go, if you go over here and just type in ASCII table. Oh, is that a good one? So here they are right here. Okay. And so you can see here, here's the numbers right here. And here they are in decimal, here they are in hexadecimal, octal, HTML, and what is the character. So if we're looking at it in decimal here, the number 9 is 57. If we look at 32, it's a space. And here we go. Here's 65 over here, okay, which is the A. And then that goes to 90. Oh, I said 91. That's the Z. Then we have some, brackets and stuff like that. And we get to 97. And then we have the lowercase letters, okay, that run up to 122. And then there's the extended ones. And we used to use these quite a bit when we programmed in COBOL and that, because you could draw, well, you still can. You could do this in Python. You use these blocks and things to make graphics, cheesy graphics, let's put it that way. Okay. So the charts are here. And then I was going to show you real quick here. I think I can spell it. I don't know. Yeah, there it is. So if you look here, it's a little bit different. But you see, you get to here, and here's 65 again, and it's the uppercase alphabet again. Same thing here, you get to 97. So I don't know. I know there's some differences, though. Okay. 32 is still a space, but they're not exactly the same, I don't believe. All right. So those are your symbolic tables in that. Here's kind of what we did just with our, oh, this is what it looked like if we did the same thing we just did for like grades. You put in a grade and you could do it this way, and then she converts it. Let me see if I can get her to do it here. She's programming or diagramming. But you can see here that she converts it to the else ifs from the if and the else's strung out across the page. Okay. So again, you should be familiar with these in order, just a warning. Here's the three. The hot dog one's pretty funny because you have to determine hot dogs come in a certain size. I think it's like 6 to a pack, and hot dog buns come 8 to the pack. Have you ever noticed that? That's a true thing, or whatever. Or you get 8 hot dogs, and you never have the same amount of hot dogs as buns. Let's put it that way. So this problem is they ask you how many people are coming to your party. Okay. Here, I think I can find it real quick. If I can see it here, I'm in the dark. Or if you got your book in front of you. Maybe you could read it because I'm not going to be like that. Okay, so you need to determine what is the minimum number of packages of hot dogs, the minimum number of packages of hot dog buns, and then how many are going to be left over after the party. Okay. So hot dogs, buns, you get 8 to the pack, and hot dogs, you get 10 to the pack. And so that one's kind of cool to try and figure out. Okay, when you get to it. I gave you this 20 minute, let's take a look here real quick. So you got 20 minutes to answer these questions, all right? So things like the code to assign $10 to a variable would be what? Blank is the name to represent a value in computer's memory, which may change. So which one of those would you pick? The next question is match the data type, okay? This data type stores data that cannot be used in mathematics. This one stores the data as a whole number. This one stores data as part of a number, fractional. And this thing is used to comment out anything, to make a comment. Okay, not too hard. Then the next one is put these in the order of precedence. We just went over that. What kind of language is Python? And then you can pick this last one. I think there's two. There's 2 of them that are valid out of these 5, and you have to pick them. So not a real hard program or a quiz, just a little check on you. And I think it's worth 10 points or something like that. And you got 20 minutes to do it. And there's, what I'd say, 6 questions. So make sure you knock that out, okay, this week. So, oh my gosh, I got nothing out of nothing. And so you got any questions on, oh, stop. So that's it. Not a bad, pretty easy. Make sure you understand how to do decisions. Practice the Boolean logic, especially if you have compound, if you're using your logic and if you're using more than one. I was going to say one other thing here. What was it on this one here? Let's look at this one more time, okay? So what if I told you this? Let's see here. I'm looking, if I wanted to, if you needed a program to find all female students that are taking computer science 145 that are sophomores. Okay. So now my question to you is, and let's say this is at ICC, and let's say that I think this semester we're down to about 7,500 students, and the split of gender split is about 60-40 female. My question is, how would you go about this? Which decisions would you make first? You have 3 decisions to make. Okay. You have one on gender. You have one on the class they're taking. And the other one is what?
ICC student or sophomore.
Oh, yeah. Sophomore, what grade they're in. And I will tell you that the class breakdown, I'm sorry, the year they're in school is, let's just say it's also about 60-40, really. 60 freshmen, 40% sophomore. So I'm going to say that's gender. So this, let's do it this way. So we got gender, class. By class, I mean, are they sophomore or freshman? And course means what course they're in. So now I want to know here, in order, how would you go about this?
I would go gender and then class and then course.
Okay. So he's saying that he's going to go gender just the way they are. Right? 2, 3. Okay. Who was that said that?
That was me,
That was you. Which one is you?
James.
James. Okay. Who agrees with James?
Yeah, I
I
agree.
You want the first condition you pick should be the one that narrows it down the most. So you
Okay,
go
who's
from more
talking
general
right
to more
now?
specific. David.
Okay, so David, what's your scenario?
What's my scenario?
Yeah.
Male. I don't know what class I'm in. I already have a bachelor's degree, and
No, you're here. This is a ICC student.
so what are you asking me?
Which order would you put these in when you compare them?
Oh, gender, then class, and then course.
Okay, so you're with James then, because that's what he said.
Yes.
Nathan, how about you, buddy?
Yeah, I mean, I think that's a totally fair logic.
Christina or Andrea, are you with these guys?
If
Yeah.
you're looking for a female in the computer science 145, that's a sophomore. There's probably going to be a lot less people in 145, so I was thinking that would be first.
So she says that she thinks this is first. Okay.
Oh, yeah, I could see that.
What's your next one?
Either of them would work because they're both a breakdown of 60-40.
Yeah. Probably go with the women here. Oops, sorry. Because in computer science, right? How many women are in this class?
2.
2, right? So then we go here for 3. Okay. Now, just think about it. There's, let's say there's 16 of you guys that are supposed to be in this class. So there's 7,500 people. And by choosing course first, okay, I end up with this is how many I get rid of in my first decision. Is that good?
No.
Yes, it is.
Yes.
Because I only have to do one thing and I already got rid of that many people.
But wouldn't that take a really long time?
Think about it. If I don't do that, if I split them 60-40, after the first thing, I still got to go through all 7,500, right?
Yeah.
But then I only got, so if I did it the other way, if I did 7,500 here, and I'm just going to guess, and I say, okay, I get rid of 40% of those, I don't know what it's going to be. Let's say 3,000. Okay. When I go to do the second comparison, okay, right? I still have 3,000 people I have to do. Over here, I only got 16 people to do. How much faster is this going to be than this is going to be? See what I'm saying? Yes, no? And then just think about it really here. I've got 16 people to do. If I do gender next, okay, I end up with, I'm going to get rid of, well, I'll only have 2 here. Over here, I'm going to have another 60-40 split. So half of three, so I'm going to get rid of 2,000. Oops, that was wrong. This is actually, this is going to be equal to this, no, this minus this. I still got 1,000 here to do. Or no, that's how many I got rid of. Over here, I get rid of another 16 or 14, leaving me my 2 here that would qualify if they're sophomores. I don't know what they are or not. And I'm still stuck over here going through 2,000 more to determine if they're sophomores or not. So there is an order, a logical order to do things is my point, okay? That you have to think about. How can I get rid of the most of the things I don't want the quickest? Okay. Any questions? I'm going to go. Go ahead.
On the lesson 1 quiz, the question about the order of precedence, I think that's messed up.
Hey, hang on a second. It might be. I'm not saying it isn't.
I agree with him.
Okay. Let's see what we get here. Okay.
Is this all just bonus for us, or?
No, you got to take this. It is messed up. Why is that?
Oh, I see it now.
Okay. Here, I'll fix it. Addition, 1. That's crazy. Why is that? All right. So this should have been, this is hard, huh? Here I am typing in the answers in front of you. So this is exponents. Oh no, parentheses, right? And then the next one down should have been exponents. And the next one down should have been multiplication, division, and remainder. And then the next one down would have been addition, subtraction. All right, and then I guess that's right. Position 1, correct positions 3. Okay, I guess it does them that way. Okay. This will affect 6 attempts. Okay. There we go. And let's go here. Somebody got a 20. Okay. So here. So that one I cleared. So people that have already taken it, you get to take it over again. How fair is this, huh? It's almost scary. All right. Oh, Isaac, you better take it better. Okay, so everybody now should have should be able to retake that.
One more thing while you're already at Blackboard,
Yeah.
if it wouldn't be too hard, could you just put like a link on that sidebar that you're currently looking at to the Zoom class?
I thought it was there.
I ended up finally just finding it in your information.
Yeah, me too. And it's not a big deal.
I mean, it's right here
right.
under the professor. But yeah, I can put a here. How's that? Oh,
That's
no,
perfect.
it's not going to let me. Hang on. I need to copy this right here. Control C. See if I got it this time. Somebody go ahead and try and see. Oh, well, I guess you can't. You could, I guess. I don't know. It should work. Okay, so I'm going to stop sharing. So that's good. I'm going to stop recording.